What you're going to see is some material is adapted from training material that I produced for my colleagues at Descartes Labs. It includes a lot of original diagrams and information, but I've also borrowed liberally from the Istio community, diagrams from YouTube talks I watch, blog posts, things like that. I have tried my best to attribute all of them. If I fail to say out loud what I've attributed, the actual source of some of this material, it will be in the speaker notes, and I'm going to provide a link to the deck at the end, so you can follow up on any of that interesting stuff, because there's lots of deep depth in those resources for any topics you might be interested in. I'm also going to try to unravel some Istio and Envoy terminology as we go along, but if I do use a term you're not familiar with, feel free to PM me in the Slack or find me another way, and I can try and explain that. The only assumption I have is that you have a pretty good understanding of Kubernetes already, and Kubernetes, sort of vanilla Kubernetes networking. And from there, we'll get into how Istio works. So this is me, frequently seen wearing unusual hats on the internet. Not an Istio maintainer, just a longtime user. I joined this organization, Descartes Labs, a little over 2 years ago. We had production Istio in place when I joined. It was my first experience with it. So everything comes today just from hard-earned shin banging on rough edges and things of the wisdom of production, as they call it. So if I say something today that's not true, that's totally on me and me failing to understand something. I really look forward to being corrected by people watching who understand this stuff maybe better than I do. And I provide the Twitter link not because you should follow me, because for me, Twitter's just the pillow that I scream into. It's mostly me swearing at the cloud, but I will tweet a link to this deck afterwards, and you can find those links I mentioned. Okay, today we're going to talk about these 4 subjects, a little bit about what IstioD is and how it interacts with Kubernetes and Envoy. Talk briefly about exactly what Envoy is, although we've already heard some of that today, so hopefully we can buzz right through that. We're going to go deep into how Envoy works, and we're going to, at the end, we'll take a brief sort of high-level tour of what an Istio-generated Envoy config actually looks like, and it's pretty beefy. Okay. So this is what the Envoy community would refer to as an Envoy management server. I think it was mentioned already in one of the talks today that actually it was like during the opening statements, I think. Somebody's talking about originally getting with Matt from Lyft and talking about how to program this proxy that they released. And if you actually go to the Envoy proxy GitHub org, you can find a project called the Go control plane, which is sort of the canonical way to control Envoy proxies, which is what IstioD is sort of built on top of. Other names that you will hear for IstioD floating around the community because of the sort of winding path that it has taken to where it is today. You'll sometimes hear it referred to as Pilot or Discovery or the Istio Discovery Service, kind of just leftover names that people use in GitHub issues and things. So if you see that, that's what they're talking about. This is a dramatic oversimplification of the architecture. I've got a link here in the notes, so it'll take you to a more complete description of that. But we're going to talk about a couple of these components today. And specifically, well, okay, so there's, that does more than just that. So there's lots of logic in IstioD. But we'll get to some of that in a second. We're also going to skip Citadel completely. This is the component that handles certificate signing. If you're very interested in that topic, there's a talk tomorrow that looks like it's going to cover that stuff called Know Your Peers by Alex von Boxel. I think that's where you'll find, a deeper discussion of these things. But for now, we're going to talk about Galley and Pilot, and we'll start with Galley. So what I would consider the core function of IstioD to be is to read from Kubernetes and write to Envoy. It's sort of a one-way pipe in general. And if you deign to read the Istio docs, which you should, what you will find is that it says very clearly, quote, Istio does not provide service discovery, end quote. I don't know who wrote that, and if they're here today, maybe they can explain to me what that means, because one of the things that Galley does is it discovers services in Kubernetes. It also contains a service registry where it sort of keeps track of all the things that it's discovered. Obviously, it has native support to discover services inside of the Kubernetes ecosystem, but it actually came originally with other service discovery mechanisms. Now, those mechanisms aren't as important in the Kubernetes world that we live in today, but they are kind of being subsumed by a technology they community refers to as the Mesh Configuration Protocol. You can abbreviate it as MCP all over the place. This is a mechanism that will allow you to sort of generically reach into Istio and tell it about things that maybe it doesn't know about yet. So this would be something like Google has a project called Traffic Director, but you can imagine a scenario where a managed service can reach into your cluster and say like, oh, that managed Redis instance you just launched, it's now reachable from inside the service mesh, and it would be achievable through this mechanism. And sort of taking over the service discovery Istio to see what it has discovered when it wasn't doing service discovery. You can port forward to this port here and check out this endpoint, and then inside of it provides all these debug endpoints where you can get a list of all the services it's discovered, all the endpoints, things like that. In the notes with the slide deck, you'll find a link to a complete list of all the debug endpoints that are available. Okay, beyond service discovery, Galley also serves webhook requests. Now, there's been a little conversation about how Istio leverages Kubernetes webhooks to provide some of the services that it does. So I'll just sort of skim through this briefly. But basically, the two primary types of webhook that are utilized are the mutating and validating webhooks. So there's a mutating webhook, which is utilized to deliver the pod injection. So what happens is you or something we're operating on your behalf will say to the Kubernetes API, please create a pod. When that happens, the webhook configuration causes Kubernetes API to fire a request over to Galley saying, here's the pod I'm about to create. It will then munge the YAML, hand it back. And when it's done, now that pod will have a sidecar and init container and so forth attached to it. And same thing for the validating webhook that's used for if you kubectl apply some CRD YAML, gets passed over to Istio for validation. If it's something wrong with it, it will try to send back like a help error message. And so those two webhooks work. And this diagram is lifted from the Galley design doc, which is also linked in here. This is the specification, which tells Kubernetes how to execute the webhook. So in this case, you can see that anytime these API objects are either created or updated, it's going to cause a payload to be posted to a service of this name in a namespace of this name at this URI. And same thing for pod creation. This is how the mutating webhook is configured. So pretty straightforward Kubernetes CRD setup. One interesting side note, the IstioCon CLI pronunciation. The IstioCon CLI actually not duplicates, but reuses a lot of the logic for the pod munging. So if you're curious about what is exactly going to happen to your pod spec when this webhook is executed, you can test it using a command like this, and the pod injection is actually quite configurable. So you can use this to test your tweaks to the pod injection logic and run it all completely offline. So you can just make sure that's going to work before you put it up in the cluster. Okay, so that's Galley, talking to Kubernetes, reading from Kubernetes, understanding Kubernetes. We'll talk a little bit about Pilot. Pilot takes the services discovered by Galley, and so that's where it maintains this state of the world. And then it takes that information and uses it to program Envoy. Now, this is a slide that lifted from a talk given by Niraj Patar, who spoke earlier, and John Howard, who's going to speak. Actually, I think he already did, but he's probably going to speak again because he's everywhere. Talk called Debugging Your Debugging Tools, and I've got a link for that as well. What I want to, it's not important that you understand everything in this slide. I think I really want to get the point across is that you can see there's this very linear relationship between like Kubernetes object, Envoy thing. There is a clear path from Kubernetes through Istio to Envoy for a lot of these objects. Okay, and that's all we're going to say about Pilot, because really what Pilot does is less interesting. What's more interesting is how Envoy responds to what Pilot sends down. Okay, so you're right. Now we'll move into the insides of Envoy world. This is how you can tell that an Envoy is not a commercial product, because when you go to the What is Envoy page, it tells you. It's very simple. This is lifted from Matt Klein's Envoy Internals Deep Dive presentation, which is very good. He gave it all over the place. You should definitely check it out if you haven't seen it. A lot of stuff isn't important for our needs today. What you can tell is that it's thoroughly buzzword compliant, and we're going to get into a couple of these things in a bit. One interesting thing, which I think probably I mentioned earlier, is that Istio uses a fork of Envoy. Why is that? Well, that's because Istio adds a considerable amount of functionality to Envoy. And as you have probably already heard, and we'll hear more of this week, that functionality is going to be provided through WebAssembly extensions as opposed to compiled in static extensions. But for the time being, most of the stuff that Istio adds to Envoy is actually still written in sort of static C++ that goes through this WebAssembly null VM thing that you'll hear more about later this week. But this is why we need a fork. And eventually the fork will go away. You'll be able to do this dynamic module, like add all the functionality that Istio needs dynamically. But until then, we're stuck with this fork. Incidentally, John, again, if he says something, he's probably right about Istio anyway. Okay, terminology. I just like these terms, but we have to talk about them because they're used everywhere. In Envoy land, downstream means where connections come from, and upstream means where connections go to. So this is like, clients and backend services. You can essentially think of these as. I had a really hard time getting these words to stick in my head when I first started. I find drawing your network diagram this way kind of helps orient those words in my head anyway. If you think about sort of the idea of north-south traffic, so from this proxy's perspective, here's a front-end app with a sidecar. The clients are downstream and the backend is upstream. And then from this proxy's perspective, the front end is downstream and some other backend service is upstream. So anyway, I'm going to say that a bunch. Hopefully that settles in your head. I've also found this metaphor helpful. What you should do is abandon any metaphor that uses water because the stream part doesn't make any sense there, but hopefully that helps. And then the other important terminology that we need to talk about are clusters and endpoints and listeners and routes. Again, these are all first-class Envoy constructs. You can think of clusters and endpoints as basically host names and IP addresses. Cluster is an unfortunate name, perhaps, because we spend a lot of time talking about Kubernetes clusters, and an Envoy cluster is not a Kubernetes cluster. It's basically a host name. It's like some abstract thing to put in front of one or more IP addresses. These are all examples of cluster names that Istio would create for you that would program a sidecar with names such as these. As you can see, they don't comply to sort of normal looking DNS host names that you might be familiar with. But yeah, these are all totally valid. And then listeners and routes basically describe sort of, what to listen to and what to do with it and where to send it. Routes are where to send it. So what to listen to, that is usually going to be like an IP and a port for TCP and UDP traffic. It could also be a path for a Unix domain socket. And then the listener is also going to configure what in Envoy parlance is considered a set of filters into a filter chain, and that's attached to a listener, and those filters define the logic of how that connection is processed before it gets routed somewhere. And then a route is a special type of Envoy object that only pertains to HTTP traffic, and that's used for matching the properties of an incoming request to some backend. So you can imagine, if the header is this, then it goes to that service. If the URI is that, it goes to this service, things like that. So sort of basic, Nginx type stuff. Okay, so with those terms in mind, now we're going to look into how they function. I lifted this diagram directly from the Envoy blog, from a post called How to Write Envoy Filters Like a Ninja, which I've got linked here as well. But this is sort of to give you a sense of what I'm talking about when I'm talking about the filter chain. Now, I'm going to use sort of an abstract metaphor here, and hopefully most of the folks in the room are familiar with some basic Python. But what we're looking at here is a fully functioned Python web application. Very simple one. And we're just going to sort of use this as a mental model to think about a filter chain. So in this case, in order for this web app to function, you have to define a function that complies to the reference function signature. The WSGI is the sort of this canonical Python method for serving web traffic. So you have to match this function signature. You have to call this start response function, and then you have to return a response body, and that's it. Now you've got a functioning web app, and you can run this web app like we're doing down here, and send it a simple web request in, and get a response back. And you can imagine that when you're running this Python process, somewhere between sending this extremely simple client request and executing the Python logic, some extra processing had to happen. Somebody had to decode a TCP byte stream, recognize that it's HTTP, like decode that into HTTP, and then turn it into Python data types that are suitable for calling a function. And so if you're going to do that in an Envoy filter chain, it might look something like this. You'd start by reading a raw block of TCP bytes, trying to interpret them as HTTP, and then converting them into Python data types, and then maybe calling some link function. Now there are no I don't think anyone's doing Envoy filters like that, but this is what you're looking at here is the simplest possible Envoy filter chain, which is an empty one. And the default behavior of an empty filter chain is to close the connection. And so a chain that goes nowhere, an empty chain, is how outbound traffic policy is enforced. You'll wind up with an Envoy listener that has an empty filter chain, and that's it. The connection just gets dropped. And I think in practice, actually, it's not empty. I think the stats filter is always there to provide those nice metrics that you see in Kali and Prometheus and things. But yeah, as long if the end of the chain isn't a outbound connection somewhere, then it just gets closed. So we've got just an example here to think about of a source and destination app. You've got some source app, it's got a couple of pods in it, got a destination Kubernetes service. You're going to send a request to, and we know that this service is going to get discovered by Galley, right? We already talked about Galley's out there looking for services, and when it finds a service like this one, it's going to produce a filter chain that looks something like this. So it's got a listener that matches the service VIP, and it's got a single a link in the filter chain, which is just the TCP proxy filter, and all it does, it's just a dumb carbon copy the bytes over in this direction kind of thing, and it's going to send it to a specific Envoy cluster, if you know, it's like a host name that represents some number of backend that are capable of servicing the request. So this is what that same filter chain looks like in an actual Envoy configuration. And you can get Envoy any sidecar to display this stuff for you by using the IstioCon proxy config command. You can ask for the current listeners, routes, etc. that are configured. And so you can see this is, again, the listener name, TCP proxy is the only link in this chain, and there's the outbound destination cluster. Now in practice, like I said, Istio always injects the stats filter, which is part of the reason. This is why you go out and spend big money on Istio, because you get all this visibility. And so even for a simple TCP proxy, you're always going to see this in here. And then incidentally, if you're looking at your Istio metrics, and when you see CX as a suffix, like _CX as a suffix on a metric name, that means connection, which means that the statistic was generated by the TCP stats filter. And if you see RQ, that means request, which means the statistic was generated by the HTTP stats filter, which understands HTTP and gives you a little more fidelity there. Okay, now I've said the word extension a couple of times. I may have said plugin, but you'll find in Envoy and in Slack and GitHub and so forth, people will sort of use the words extension and plugin interchangeably to describe basically any of the code that hooks into Envoy to expand its functionality. And while it's true that all of the filters in the filter chain that we're talking about are extensions, not all extensions are filters, or they're extensions that do all kinds of other things. This is just some of the things, some of the Istio functionality that's I shouldn't say not just Istio, but also Envoy functionality that's provided by extensions that have nothing to do with being part of the filter chain. So when I think of the data plane, I think of just that filter chain. That is the heart of the filter chain. So these are the types of filters that can be assembled to compose a chain. And there are more than these. These are just sort of the core ones that we're going to talk about. So listener filters always executed first. They typically are going to inspect an incoming connection and try to learn something about what the nature of that connection, and then attach a little bit of metadata to inside of Istio memory, or the sidecar memory, I should say, about what it's found. So typically this looks like checking to see if it's TLS. If it's TLS, then this like a Boolean gets set. You're checking to see if it's HTTP, that sort of thing. And then usually what that means is that a particular network filter winds up processing that connection based on what's discovered by the listener filter. Now, network filters tend to be layer 7 aware, so you're going to find network filters out there for Redis, Kafka, Mongo, things like that. Typically, a network filter is going to implement some kind of layer 7 features usually something like application-aware connection pooling or smart routing, something like that. And if you think about it, I mean, you could implement an entire network service right in a network filter, actually. And in fact, Envoy comes with a couple of them. There's an echo filter and an HTTP direct response filter that you can program to say, if a request comes to /foo, return a 500 or something like that. I mean, technically, that's a complete service. And then just because HTTP is so important on the modern web, there's a whole subcategory of network filter that are just HTTP filters. So the HTTP network filter is called the HTTP Connection Manager. You'll frequently see this shortened to just HCM. And the HTTP Connection Manager then has many other filters that can hang off of that to provide HTTP functionality. So this is where you get your rate limiting, gzip compression, request routing, CORS headers, all that stuff is all implemented as HTTP filters. Okay, so we're going to step through this. Listener filters always executed first. They're asking some sort of question. They're providing metadata. Now we move on to the HCM. This is where we start decoding TCP bytes into real HTTP constructs. Then we start providing our HTTP value. You know, we're collecting HTTP stats. We're injecting headers and stuff like that. Now it's worth pointing out that the HTTP router filter needs to be present. Otherwise, the request doesn't go anywhere. So it's usually the last one in the filter chain. And then once the request gets routed, well, that little red arrow there is actually doing a lot of heavy lifting. So we're going to take a quick diversion to just talk about how requests actually get routed. Now, this diagram also lifted from Matt Klein's Envoy Internals Deep Dive talk, which again, linked here. Please go watch it. You will learn things. There's a lot more going on here than we're going to talk about. But so far, with the little filter diagram that I showed, we have traversed this much of the path. So keeping in mind that cluster means host name and upstream means where connections go, once a routing decision has been made by some filter, either TCP or HTTP, that filter is then going to ask the cluster manager for a connection to an upstream service. And that's sort of this component here. So there's a manager for all these Envoy constructs. And the cluster manager handles things like knowing which endpoints are healthy and doing load balancing and connection pooling and those sorts of things. This is an alternate diagram lifted from the Envoy docs, just to sort of give you a different visual representation of how the managers relate to clusters and listeners that they're responsible for. Okay, so with that little red arrow covered, there's one more filter abstraction worth talking about before we move on. And that is this thing called the filter chain match. And the filter chain match basically allows you to make a choice about which filters are going to be applied based on what the listener filters discover. And so remember, we talked about listener filters, doing some sort of test and reporting back. And then once they've extracted some information about an inbound connection, you can use the filter chain match to test those properties that were discovered by the listener filters, and then go down one of several arbitrary paths. So for example, if you determine that the incoming connection is HTTP because the HTTP listener filter determined that that's true, then you can pass it off to the HTTP connection manager and then do your HTTP routing and so forth. And if you can't determine that it's HTTP, it's probably safe to just treat it as TCP. So that's the default. And then route it to an upstream cluster. And this is what that looks like in an actual Envoy config. So here you've got this listener. This one's listening on this 1510. And you can see the filter chain matches here. And basically it says if this happens to be HTTP 1, 1.1, or 2, then we're going to apply the filters found in this list. And this is the empty match condition. If any other connection essentially that is not these things, we're going to apply the filters found in this filter chain here. And to be clear, I really want to just connect these sort of abstract ideas to the concrete Envoy configs you're going to find, because sooner or later you're going to find yourself dumping Envoy configs and looking at them and scratching your head, and hopefully this will help with that exercise. Okay, so thinking about that example of connecting from some source app to some destination app that was discovered by Galley, and which then composed a complete filter chain for proxying TCP requests to that service. When the source app actually makes an outbound request to this IP address and this port, how does it actually end up in the Envoy process in the same pod instead of actually being routed out through the network interface to where it's supposed to be going? Well, if you've been around Kubernetes for 4 seconds, you'll know that everything is done with iptables. And this is how we do this here too. So this is a dump of all of the iptables rules from inside of a pod with an Istio sidecar. These have all been added as part of the sidecar injection process by an init container, and that logic for that lives inside of a command called pilot agent, which you can find in the repo. It also does a bunch of other useful stuff. I'm going to sort of briefly summarize what you find here, but if you're interested more about this, Jimmy Song, who's speaking later today during the Chinese track, has an astoundingly in-depth blog post about how all of this stuff works, linked in the slide notes here, and strongly recommended. So basically what we see here is that we're telling any outbound connection coming out of this pod to pass through that particular iptables chain. The whole chain is out here, but most of it is not important. All we're really saying is that anything that goes, basically anything, not everything, but basically anything that comes out of this pod needs to pass through this one chain. And that chain is going to redirect it to localhost 15,001. And the same thing is actually done for traffic coming into this pod on 15,006. And what that means is that you can pop into a sidecar pod, pop into a pod and look and dump the listening processes from that sidecar. And what you'll find is that there's actually only 2 ports listening for all of this traffic. I mean, a couple other sort of maintenance ports, there's like debug port and stats port and things like that. But 15,001, 15,006, this is the only place that data plane traffic is passing through. And this is sort of this sort of secret of an Envoy listener that you don't see documented really well anywhere, is that most of them are logical. Most of them don't actually open ports. So the way this all fits together is that you've got your source app, it shoots a laser out, TCP-shaped laser, bounces off an iptables mirror, goes into an actually open port on this virtual outbound, makes its way into a filter chain, gets processed, and then the pass-through cluster, which is sort of the default destination for a lot of traffic that hasn't been matched yet, has this option called original DST, which uses iptables kernel magic that I don't understand to recover the original destination port and IP address for this request after it has been rewritten by iptables. iptables has hidden it somewhere and allows it to be recovered. So he starts out with a destination IP and port here, gets rewritten by iptables to this, but by the time it pops out this end, it's actually been restored. And so what that means is that now Envoy can look through the entire collection of listeners, this huge list of all these other services in the cluster, and see do any of these match. And if it finds one that matches the characteristics of the now restored port and IP, then it can use that as a match and execute the filter chain, pass the connection through that filter chain. Okay, so with that bit of sort of how Envoy functions taken care of, we're going to move on to talking about how the Envoy configuration looks. And like I said, I do this because eventually, sooner or later, you're going to have to dump a sidecar config and have a look at it, and it's a little bit daunting. So I stole this screenshot from a screencast from the solo.io folks, particularly this fella Yuval, who's going to be speaking here as well this week. He and Edith, who you saw speaking earlier, are going to be talking about WASM filters. I guarantee you will learn something from them. They're very smart people. I've got a link to this as well in the notes. And he's absolutely right. In this talk, he, even though YouTube flubbed the transcription, Envoy config is not meant for human consumption. It's not fit for man or beast, mostly machines. Now, this is a full, complete Envoy config. I pulled it right out of the Envoy docs. Seems like it could be reasonable. However, this is an Envoy config that Istio generated in an otherwise completely empty cluster. I managed to pack this mere 90 kilobytes of JSON into 2.5 megabytes of PNG so I could show you this high level view. We are absolutely not going to go drill down to what these lines mean. I'm just going to give you a high level overview of sort of the 10,000 foot view. Okay, everything to the left of this line is Bootstrap. Remember I talked about the pilot agent, the init container that goes into the sidecar? This is all provided by the pilot agent. This is just get Envoy off the ground. This is where that comes from. Up here, you've got things about the node. In this case, it's just a pod. So like, what is the pod name? What cluster version is it? And so forth. Here, this is all extension and initialization boilerplate. So all those extensions we talked about, the ones that could be filters or not filters or extending Istio in some way. This is all initialized here. Down here, we're bootstrapping Prometheus metrics and the health check endpoints. We're setting up local clusters, and then we're talking about Envoy clusters. So these are like places that you could send a request to. In this case, they're the local Prometheus endpoint that provides the metrics, how to find IstioD, and how to find Zipkin for if you're tracing. Here we're bootstrapping metrics and logging and the tracing configuration. And that's it. That's bootstrap out of the way. So forget about that. In here, all that is a list of clusters. And like I said, I pulled this Envoy config out of an otherwise empty GKE cluster. So this is just like, the default Kubernetes services that Galley discovered out of a mostly empty cluster. So it's like, Kubernetes master, like the API server, whatever else is in there, shows up in this big list. And this is all, been pushed down by IstioD. So forget about that list of clusters. Okay, now we're into listeners. This is probably where you're going to want to look if you wind up with a Istio config that isn't doing what you think it's going to be, we thought it would do. This is the part where you're actually going to want to scroll past all that other stuff and look here, because this is where things like routing matches are going to happen, like checking headers, checking URIs, things like that. We also have routes down here as well as listeners. These are both the static and dynamic routes. And like I said, those things that are places that you could send an HTTP request if it matched some characteristics. And then finally, you're gonna have secrets. So these would be the MTLS certificates for mutual, like in mesh traffic. And if you happen to be looking at the ingress gateway, you'll find your client terminating secrets there as well. Okay, so that's it. So I mean, there's really a lot here, but most of it is boilerplate and a list of clusters. That's it. You can skip over almost all of it when you're debugging, even though it looks pretty intimidating. So now there's this little block that isn't colored in. This is a magic piece of Bootstrap that basically tells Envoy, now that you've started up, where do you go for more information? And basically, this is telling Envoy, go talk to IstioD for all the important things that Galley's discovering. And so there is a cluster called XDS gRPC, and this is how it looks in the static cluster definition. Basically, a service called IstioD in a namespace called IstioSystem on a port far, far away, and that gets your sidecar started. Okay, so that's Envoy config. I'm going to park it right there. I know that was a lot, so here's some cute pictures to soothe the spirit. And I genuinely hope I didn't make too many grievous errors, and I genuinely hope people learned a new thing today.